would like to introduce Ned Dorji, who's a master's student here at Curtin, and his project has been supported by the State Library of Western Australia. I've been the primary academic supervisor on this project, and I'd like to thank Barbara Parnaby, Deborah Jones, who are both here this morning, yeah, over to you, Ned.
All right. Thank you, Andrew. I'm Ned, and over the last 10 weeks, I've been working on developing an interactive kiosk version of OldPerth. The main aim of the project was to build a self-content, user-focused, and interactive experience based on the currently existing OldPerth website to make it suitable for public use in the state library within the Perth Cultural Centre. And to achieve this, we modified and added new features to the website. There were 3 primary goals for the project. We wanted to replace any external links from the website with an alternative method that would still continue to provide access to the content and does not hinder the original functionality of OldPerth. We wanted to create an automatic interactive feature that would capture users' attention, such as automatically displaying a randomized image from different locations. And finally, we wanted to identify ways to include other file formats such as audio and video files. And here's a bit of a background of how OldPerth was first developed and how it works. Many people have worked on this project, including Andrew here. Mark Shelton, who was one of the former interns, primarily worked on developing the prototype for the website, whereas Max Collins, who was also a former intern, worked on actually developing the website. And OldPerth is like a Google Map interface that loads up images instead of providing user with the information about a location. The platform currently features over 10,000 geolocated images from various locations within Perth and its surrounding areas. These images are, as you can see, displayed on an interactive map where users can come and interact with it. The website's front end, which is the part where you can see, is built on the source code developed by Dan Van, who developed this as a part of his old NYC program. Although OldPerth shares some basic functionalities similar to old NYC, some of the features have been modified to cater specifically to Perth. Max Collins, who I mentioned earlier, completely redesigned the framework for processing the library catalog data. He created a Python package known as libclean. Using libclean not only simplifies reading the standard library catalog data, such as MARC files, which are commonly referred as machine-readable cataloging files, but it also offers the functionalities to geolocate images based on the metadata extracted. Although MARC files are machine-friendly, because of their complex structure, it is harder to interpret them. So libclean overcomes that challenge by making the metadata extraction easier. So on the figure over there, here, this is a simple logic of how OldPerth works. OldPerth client, which is a window executable program, is an easy way to update the OldPerth website without requiring any programming skills. So it is, in fact, the central program that connects everything together of how OldPerth works. And even if you don't have coding skills, you can use that program to update the website. And I have made use of that program quite a lot during the project. As you can see, libclean also has so many other functionalities, and one of the functionalities is its ability to correct the image address based on the user feedback through a Google form integrated onto the website. Once the suggested correction is verified, new latitude and longitude coordinates are generated for the image. LibClean also has the functionality to feed the geolocated data back to the state library, and by doing this, it ensures that both OldPerth and the state library have the same validated addresses. So, with all these robust functionalities, you might be wondering, like, why couldn't we just use the existing OldPerth website for Kiosk purposes? Well, there are several considerations when putting a website on a publicly accessible console. Number one is the current OldPerth website has so many external links, which increases the risk of users unintentionally navigating to unauthorized websites through the links. And for the Kiosk version, we absolutely do not want that from happening. And the website remains inactive as long as there's no user interaction right now. And for the Kiosk version, as I mentioned earlier, we want to be able to capture users' attention by automatically loading some images from different locations. And finally, we don't want users to be confused with the random information on the kiosk. For instance, if a previous user leaves the map on an empty field, it significantly reduces the likelihood of new users coming to the kiosk and interacting with it. So one of the ways we thought was best to replace the external links on the website was using QR codes. By incorporating QR codes into the website, it restricts the users from being redirected through the external links. It still provides the user with the access to the content, but they'll have to use their own device at their own time. And this also ensures that the security of the kiosk is not compromised. Personally, I believe that using QR codes is in line with the modern digital practices, especially where QR code has become a popular and widely accepted way of accessing information. So during the QR code integration to the site, there were two important considerations we had to take. Number one was, how do we replace the static links, like social media links on the website? And another one was, how do we replace the dynamic image links, which are sourced from the state library's database? So here is a simple flowchart of how QR code generation works. There are two ways in which QR code is generated. One is through a on-click event listener from a tag in the HTML file, and another is through the dynamic image link, which are generated according to users' interaction on the website. Once the QR code is generated, it automatically closes after 20 seconds, and we can always adjust this time, but at the moment we believe that 20 seconds is enough time for the users to take out their device and scan it. And this also ensures uninterrupted execution of other features, such as the features that I'll be talking later, and without affecting the visuals and the overall user experience. So currently we have replaced around 17 static links and more than 10,000 image links that are linked to the state library's catalog. What happens if the user left the map in an empty area? Will that be interesting to the users? What is the likelihood that the users would come to to the kiosk and start interacting with it? What about now? When there's like some features that randomly pops up, displays an interesting information on the website, does it increase the likelihood of users coming to the kiosk and interacting with it? Yes. We hope so, yeah. So we needed to create a functionality that doesn't allow the website to remain idle. So we came up with this function where we load up random images from different locations. For instance, if there's no user activity within the 30 seconds after the website is being loaded, it will randomly select a location and display images from that location. If there's only one image in that location, the image will be shown for 10 seconds. And if there are more than one images on that location, it iterates up to 5 images, with each image being displayed for 10 seconds. And the reason for the limitation is to prevent the program from getting stuck in a single location where in some cases there are location where there are more than 30 images. So after displaying the images, it will move to another random location if there's no user interactivity. This cycle continues unless a user interacts with the kiosk, at which point the automatic interactive feature will immediately stop and let the user use it as they wish. So as I mentioned earlier, imagine if the previous user left the map on an empty field or some uninteresting field. That would neither be informative nor would it be useful to anyone seeing it. So to prevent this, the website also automatically resets itself in two conditions. The website resets when there is a physical layout change on the website and there is no subsequent user. What I mean by this is, for instance, if someone used the website and put a filter on it to display just one location here. So if that happens, the website would automatically reset, given that that user who filtered that website is no longer using it. Secondly, the website resets if no one has interacted with the website for 5 minutes. By having this automatic resetting, it prevents new users from becoming confused with the random information being displayed on the website. More importantly, this also resets the Kiosk version to show only the interesting area, which is mostly the Perth CBD, where majority of images are geolocated. So here is a simple flowchart of how automatic resetting works. So as I mentioned earlier, when the website is first loaded, it detects whether there's a user activity or not. And if there's a user activity, then it looks at whether the user is changing the layout or not. And if there's a layout change and no subsequent user is using it, then it automatically resets. On the other hand, when the website is first loaded and there's no one using it, it will start the interactive process, which is popping up those random images. And during the interactive process, if a user comes to the kiosk and start interacting with the website, it will immediately stop the interactive process and wait for the next idle state. Whereas during the interactive process, if there's no one using it, it checks whether the website has been inactive for 5 minutes. And if it has been, then it will automatically reset itself. So another goal we had in this project was to include other heritage collection formats, such as audio and videos. But geolocating audios and videos using the currently existing OldPerth geolocation process is not feasible, mainly because of the differences in the data structure. And it's also due to the fact that audios and videos are dynamic in nature. So we do not know what's the exact location, where do we locate? Because it's a moving frames and there are a lot of locations the authors are talking about. So we are not able to find an exact location to put the images on. So at the moment, we manually geolocated 3 audios and 4 video files. Despite manually geolocating it, there are some limitations due to the way in which OldPerth works. So as you can see in the images here, OldPerth uses PNG file format to show the thumbnails here. And it uses the JPEG file format to show the preview here. And for the audio files, we cannot show the preview because it doesn't exist in the state library's database. And on top of this, we cannot play the audio and videos on the site because we do not currently have the functionalities built on the website. So at this point, we were even wondering, like, is there any point in including audios and videos? But I'm pretty sure, like, in the future, there will be future interns coming and working on this project and, getting it much better. Nonetheless, the OldPerth Kiosk version is ready to be deployed, but there are few areas in which it could be further optimized. The backend could be redeveloped to geolocate audios and videos easily, just like the way images are geolocated currently. The Kiosk version could be fully made offline by running it locally on the kiosk instead of running it over the internet. This would require storing the images, audios, and all this content on locally, and also using an alternative Maps API because Google Maps API do not support offline mode. And conduct multiple testings and use those insights from the testings to further optimize it. At the end of the day, our goal is to make OldPerth content reach to as many people as possible and make people journey down the memory lane of Perth and its surrounding areas. So I will be demoing during the allocated time, and you're welcome to come and interact with it and help me find bugs so that we can make it better for everyone. Yeah, thank you very much. Sorry, I forgot to thank all these people for helping me during the project. Yeah, thank you.